Hello students, and welcome to another video. I'm your teacher, Mr. Flint, and today we're going to be having an instructional video on the properties of water. Now the instructions are listed here, but I'm just going to go through them and make sure that you can understand what's going on. Okay? Alright. The first part is you're going to take a piece of paper towel, it's about 2 inches wide. You're going to have a petri dish that's going to be halfway filled with water, so go get some water. There'll be a beaker of water, or you can fill it up with the sink. Alright, and you're going to submerge one end in, and you're going to watch what happens. And what's going to happen is the water's going to crawl up the paper towel. It doesn't require any energy. It's just going to happen spontaneously and on its own. And the reason is because water is polar. Water is going to have cohesive forces that keep water molecules together, and then adhesive forces where water molecules will want to stick to things like the paper and other things. So this paper towel, the water molecules are going to kind of stick to the paper towel, and then they'll have cohesion, and then they'll have adhesion, and then cohesion, and adhesion, and they kind of crawl up the paper towel. So just watch what happens and watch it go all the way to the end. And once you're done with that, you can pick it up and then throw it away. Okay. The second one is you're going to take this dropper, and you're going to see how many drops you can put on a penny. So take some of the water from your dish, and let's see how many drops you can put on the penny. And what you're going to notice is it's going to form this bubble that goes over the penny. And these are cohesive forces that are sticking together, that are making this bubble. And once you get too many, and those hydrogen bonds will break, and then the water will spill over the edge. So I want to see how many drops can you put on a penny. Okay, so that's the second one. And then the third one is you're going to take this bent paper clip, if you can see that in the video. Okay, now this is the trick to balancing a paper clip on the surface of water. Okay, so you're going to have this filled up halfway with water again, and you're going to balance this paper clip on top of your little stand, and you're going to set it on the surface of the water so that the paper clip is just floating on the top of the water. Okay, the reason this can is because it's light enough and the area is distributed enough that the hydrogen bonds don't break, and we call this surface tension. So this is light enough to sit on the surface of water without breaking through the surface and hitting the bottom of your tray. Okay, and if it does fall down, a trick to this is to dry this off again and try it. It's best if this is dry and not wet. Okay, now when you're done with this, all right, you've experienced surface tension. Those cohesive forces of those water molecules are making a bridge for that paper clip to sit on. You take a piece of soap. There'll be some over in the lab. There'll be a little tray of it. Dab your finger in the soap. It'll be in a petri dish like this. And then when this is floating around on the top of the petri dish, you're going to put your soap on the side, not on top of the paper clip, but on the side of it, and you're going to see what happens. Okay? And what should happen is the hydrogen bonds are broken, and then this paper clip should fall down to the bottom. Okay? And you can actually kind of push the paper clip around a little bit if you're careful, all right, around in the dish. How it works is the soap has a polar and a non-polar end. And one likes to stick to water, so it sticks to the water molecules. And then they have an end that doesn't like to stick to water molecules that breaks the hydrogen bonds. And then that paper clip will fall through. Important note to this is kind of like skeeter bugs, how they sit on top of the surface of water. That's why we don't put soap, okay, in the rivers. If we put soap in the rivers, aquatic life would die because they can't sit on the surface of water. Okay, all right, so we're just exploring the phenomenon. In your notebook, in your workbook, okay, you're going to write and draw out these images that you've done in your lab and use the words adhesion, cohesion, capillary action, surface tension to describe the phenomenon of water. So you're just going to experience it yourself and draw it in your book, and make sure to use those terms. Okay? Thanks again for watching. Until next time.